Okay, so welcome today to our conversation series. I think together with Heiko, I am coordinating this fantastic program on conversations on scalable interaction paradigms for pervasive computing environments this winter term, and we have great guests. So I welcome to the series of today, and I hand over to Dimitar Valkov and Lars Linsen, who are introducing our guests for today.
Hello, everyone. So I thought for this conversation could be a good idea to look at 3D interaction not from the perspective of pervasive computing, but from a perspective of virtual reality. So the first thing that came to my mind was Rob as the person that spent a lot of his research work investigating pretty much everything I can think of in terms of input devices and interfaces for usability, performance, etc., etc. In the last years, he also focused on visual haptic illusion, dynamic passive haptic for providing haptic in virtual and augmented reality. And I'm really glad he's here with us today and looking forward to hear more from him.
Thanks, Dimitar. Just because I'm not quite familiar with the format. So the presentation's quite short, is that right? 15-ish minutes or so? Okay. Mm-hmm. So I have kind of hold on a second here, sort of my boilerplate presentation here, but I'll skip to the more relevant bits then. Thanks for the introduction. So as Dimitar has said, I've done a lot of work in virtual and augmented reality, mostly kind of looking at this all from the perspective of 3D interaction in these immersive environments. So of course, this is now collectively extended reality, which is a term I'm not really super keen on, but it's something that the industry is sort of pushing towards, which is collectively mixed augmented and virtual reality. So I kind of flip-flop back and forth between calling these XR and VR or AR or MR or whatever. This is something a few years ago, if I asked in a presentation, how many of you have tried one of these systems, and 5 years ago I'd get a couple of hands up, and now I imagine that the majority of you have probably tried out these XR systems now, and so it's really come a long way in recent years, of course the obligatory Hollywood's view of these things, and this is kind of where the benchmark is set, where we want to be, right? This kind of gold standard that Hollywood has envisioned for us of being able to, like the Iron Man type thing of being able to interact with 3D content in a environment. Of course, this is some kind of, a magical augmented reality system using display technology that doesn't actually exist and probably isn't actually possible to exist. How is he holding light in his hands? Where's that being projected from? But we can get fairly close to this today with the kinds of technologies that are available. And if you haven't tried a Microsoft HoloLens, like you see at the top left here, it really doesn't look as good as it looks in this promotional imagery. But the devices like the Oculus Rift and the more recent Oculus Quest and that, these are becoming more affordable, more available. Various kinds of tracking technologies make it possible to do these. I mean, this is quite an old image now, but make it possible to do these kinds of reaching and grabbing objects in 3D environments. And in this case, he's actually wearing a haptic device, so he gets kind of a sensation of touch while he does this. So I'm mostly going to be talking about interactions. I'm kind of skipping ahead past some of the little less relevant things. And in virtual reality and 3D interaction in general is comparatively more complicated than what you would tend to deal with in 2D user interfaces. So, imagine if I'm talking about using a 2D interface like, like the PowerPoint ribbon here. Ultimately, all my interactions are boiled down to a sequence of essentially 2D point selection tasks using a mouse. I click a certain tab, I click a certain button, another flyout thing, and it's just one point selection task after another. Or as I've come to view it, the whole world of 2D interactions, just sequences of Fitts law tasks over and over and over again. Even when you're doing things like, I'm navigating a website, ultimately I'm still just doing 2D point selection tasks. I'm clicking a scroll bar and moving it around and things like this. In 3D, it's more complicated because you have to deal with, sometimes actually physically moving yourself around an environment. And when I say physically, I mean, if you've used these systems, you're aware that often you were literally walking around in these environments, and wayfinding. So kind of cognitively planning your task, but also selection and manipulation are these primary tasks in these systems, where your selection being where you're actually acquiring an object from the possible set of objects to do something subsequent with. And often that subsequent operation is manipulation, where you're either, maybe you're moving the object in 3D and or you're orienting the object in 3D, or maybe you're updating some property of the object, maybe modifying vertices or changing color or various other things. Other interactions include system control and symbolic input, or basically modifying properties of the system or the environment more globally. So maybe changing it from day to night or something like this. And symbolic input being kind of the forgotten interaction task, literally text input in 3D environments, which is not, nobody's really talking about writing dissertations in XR systems, but it's one of these tasks that you could imagine is something, maybe even if you're just designing a VR environment in 3D, or else labeling buildings in an augmented reality system, you may have need to enter text, these little phrases now and then. So these are sort of the primary interactions in 3D. So I argue that a lot of what we see in modern AR and VR systems more so, are what I kind of half jokingly call 1980s level interaction techniques. And what I mean by this is these are sort of these obvious, inspired by naturalism sort of interaction techniques. Like if I'm going to acquire an object in 3D, the first thing I'm going to try is reaching out and grabbing it. It's something that's natural from reality, and we're used to this kind of thing from reality. And arguably, it's an easy thing to learn and understand. But these are, in a lot of ways, these are quite limited. And I call these 1980s level interaction techniques because you can literally find examples of these things published as far back as the 80s, where they sort of first defined the virtual hand, or once you figure out that I don't actually want to walk around a virtual environment in order to pick up an object over there, the next thing you try is, what if I just point the controller at it instead? And lo and behold, now you have ray casting, which is also sort of right around this 1980s techniques. And here we are in 2021, and these are basically the stock interaction techniques with all of these systems today, despite the fact that researchers in these areas have figured out better ways of doing a lot of these things in the last 40-ish or so years. And so it's kind of surprising to see that, and kind of interesting to see that these things still persist, and despite the fact that they're demonstrably not the best techniques for these kinds of operations, and why are we using these? I don't know. It's kind of a ongoing question. So this is basically we can chat a little bit about today. I'm going to skip ahead a little bit here, because I'm trying to be conscious of time here, and this is a much longer presentation. But some of the main things that I've been looking at in recent years and how they pertain to mostly VR interaction, but sort of I call these holy grail problems, things that are ongoing and have been persistent issues in this area for many, many years. And so I've looked a lot at 3D selection interfaces. So how do you improve selection? This act of acquiring an object in 3D. I've also looked at, as Dimitar mentioned earlier, perceptual illusions and tactile feedback. And this is one of these sort of hot new areas where a lot of people are looking at this. How do you basically hack the user's perceptual system to do things like repurpose tactile objects in 3D, for example. And finally, cyber sickness is one of these, everybody's heard this problem with VR systems. Maybe you've experienced this, that, they have this tendency to make, under certain circumstances, to make people feel sick, physically nauseous using these systems. And so these are kind of ongoing major problems in this area that I've been looking at some of these things. So I'm going to move ahead here, just being, again, conscious of time. And when I started looking at 3D selection, this was back around 2005. So, before the Oculus Rift came on the scene and before VR sort of surged back into public view. And at the time I looked at this as you have this computing paradigm, virtual reality, or, mixed reality, augmented reality. And in a sense, these VR especially sort of evolved almost alongside the desktop paradigm. It was a little bit later, but historically it was around the same time. And in a sense, the desktop won, right? Despite all the purported benefits of 3D interaction. So why did the desktop win? And at the time when I was looking at this, I was looking at ways, I honed in on selection tasks as being one of these critical things that you can probably do this faster and more efficiently with less fatigue and so on in a desktop system. So, debatably, this might be one of the things that contributed to VR sort of going away for a little while. It's just the relative ineffectiveness of selection interfaces, and that, if I can do something faster, more effectively with less fatigue on a desktop system, and without, if VR doesn't bring any substantial benefits to these kinds of tasks, then maybe this might be an explanation for why it sort of has gone away for a while. So basically what I wanted to do was compare selection in 3D environments using a mouse to using controllers, which may sound like a strange thing to try to do. This led to a whole series of investigations, eventually settling on using Fitts law as an evaluation paradigm, which I'm assuming, I guess you guys all have HCI backgrounds, so I'm probably not going to need to explain Fitts law. So I'm going to, and again, in the interest of time, kind of skip past this. But the long and the short of it is we developed a system to present a 3D interpretation of the standard Fitts law task, and kind of presenting the sort of standard parameters you'd expect to see in Fitts law experiments, being able to vary the size and the distance between targets and things like that, to present different input methods, to be able to present targets at varying depths out of a screen. And so that you could have conditions where 2D and 3D selection were the same thing, namely at the surface of the screen, to basically establish a baseline where you could compare these things. And ultimately, we compared a bunch of different mouse and tracker based techniques, tracker being using the stylus. And by the way, these ones in the middle here are pretty much directly designed to be representative of kind of these stock 1980s level VR interaction techniques. The using a pen to touch things in 3D is basically an interpretation of a virtual hand, and the ray being, clearly an interpretation of the standard ray casting technique. And we compared this to various mouse-based approaches. And I'm kind of summarizing a whole bunch of experiments here, so I'm not going to go into the real specifics of these, but I'm happy to talk about that further later if you want to know more about it. Compared it with and without stereo display turned on, with and without head tracking in various tasks where the targets popped in or out of the screen to varying degrees stereoscopically, and ultimately found that consistently the 2D, the mouse-based techniques did better. There's an effect of dimensionality here. The lower the degrees of freedom used, generally the better the performance is going to be in these kinds of contexts. So you can see, I think, yeah, there. The mouse-based techniques were actually fairly consistent with where you'd expect mouse-based techniques to be from all the 2D studies using the mouse. The impact of tactile feedback, it was, this is this blue line here. Basically, when you're touching the screen with the stylus, you do almost basically as well as the mouse. As soon as you remove tactile feedback, it gets really bad. And the further away it gets from the screen, and when we verified this with later experiments as well that aren't seen here, Essentially, the farther away the targets get from the screen surface, whether it's, you know, into the screen or out of the screen, the worse it gets because of, well, one, the tactile feedback matters, but also stereo cue conflicts matter. Basically, your eyes will converge to where they perceive the targets to be, but they will focus to the screen surface, regardless of what depth you're converging to. And in reality, this is not how your eyes, you know, not how these stereo cues work in reality. And the ray actually did very badly in the end. Higher is better here, by the way. So I think I'm probably getting tight on time here for the presentation component. Yeah. Okay. So I'll kind of wrap up at this point. I mean, I have more I can talk about, you know, perceptual illusions and cyber sickness, but this is kind of, this 3D selection stuff is probably the bulk of my work has kind of been in this world. And I've done, you know, multiple follow-up studies with this. I still have, it's like I can never really escape from. I have students today who are continuing to do these kinds of experiments. I met with a student this morning who's in the process of writing a Fitts law framework for using on a Google Cardboard. So I can't seem to really escape this stuff, but you know, I have, if you have more questions about some of these other things, I've done various studies in looking at visual aids, you know, using eye tracking in VR, and yeah, as I mentioned before, perceptual illusions, basically looking at ways of using, this is haptic retargeting. You might have heard of this technique, but basically you can see the guy is picking up the same block repeatedly while he perceives himself as picking up a different block in the environment. So this is an example of a perceptual illusion. And we used this idea more recently, let's turn the audio off here, with a shape-changing device to stand in as a haptic prop. So the device changes shape to approximate objects in the environment. And while the user is getting redirected to always pick up the same prop over and over again, they perceive themselves as picking up a different object in the environment. So we have kind of this device to solve the shape problem, if you will. And it doesn't generalize as well as a, you know, as a true haptic system, but it provides better forces than most haptic systems, which are, you know, subject to things like the motor refresh rate and things like this. They tend to feel squishy. But it's, yeah, it's a kind of proof of concept. We're still, you know, we're looking at ways of expanding this to handle different objects. So yeah, I mean, maybe one last thing I'll briefly mention is, this is also just published at SUI. We were using a smartphone in VR as basically an interaction surface. Tactile feedback matters a lot in VR, right? It's something that's overlooked. So we had, my student developed a way to track a smartphone. Now he's actually using two smartphones here because one was going to be used with Google Cardboard, mostly because of pandemic limitations of doing the study. But he's got an optical tracking library running on the one phone. So he's actually tracking the fiducial marker displayed on the second phone. And then in this fashion, you can use a smartphone as an input device in VR. Now, you can do this with things like the Oculus Quest now, because they now allow you to access the camera tracking. But at the time when he was doing this, he started programming this about a year ago, and it wasn't available on the other devices yet. But it's kind of reassuring because right before he presented this at SUI, HTC Vive announced that this Vive Flow device you see here, where they're actually using a smartphone as an input device in VR. So it's kind of, you know, a nice sanity check when all of a sudden industry is doing something that you were talking about, you know. So I think I'm pretty well out of time here. Dimitar, stop me, because I can just keep going. That kind of gives a high level idea of some of the stuff I've been doing, and I hope you find this interesting. I'm happy to take any questions or discuss further. And I think this is meant to be more like a conversation. Is that right? Yeah. Okay.
So thanks a lot, Rob. It's a very nice talk anyways. Although only the high level version of it.
Mm-hmm.
Just asking around whether someone have a question already, or otherwise I can start. Okay, what's really interested me is you talk about haptic feedback, and that it's important, and I think we kind of, most of us kind of know this, especially in terms of precision, speed, so feeling that it's real. But you showed two different approaches. So here for the haptic feedback, I just use a haptic glove, and the other approach is to kind of instrument the environment to make it more haptically available.
Mm-hmm.
So in terms of haptic, bots maybe make sense and have their limitations. In terms of sensoric, it's pretty much the same. You can either put sensors on the hand or in the environment in order to acquire things. What is your impression? What is or could be better or worse in which situation? And I know there is no silver bullet. There is no one idea to rule them all. But what's your impression? When should I use what?
Yeah, it's a good question. I mean, you know, my slide here, I sort of lump all haptic approaches into approximately active approaches or passive approaches, right? It's not completely accurate, but it's, you know, I think it's an okay classification for most intents and purposes. And so, you know, they both have their pros and cons, right? Like if you're talking about props, like these kinds of like tracked panels, like Lindemann's thing here, or our smartphone approaches is kind of a modern interpretation of that, right? Or the classic let's track a rubber spider kind of and do arachnophobia treatment. You know, these kinds of, in a sense, these are nice because you feel real forces when you grasp these things, right? You get multiple finger contact points on these objects, in contrast to these phantom-like devices where typically you sort of only get one contact point with these things, right? Like I'm pushing a stick against things in the environment. It's kind of like if you haven't used these things before, it's kind of like holding a VR controller, but it pushes back as well, right? But the motors on these things tend not to be strong, because if they were strong, you know, they could physically injure you when they push back, right? So it kind of ends up, it's almost like a 3D analog of a mouse cursor, or being able to like kind of poke around in an environment with one finger, and you kind of it doesn't really give you in my experience anyway, not terribly realistic haptic forces. But like you say, it's not as cut and dry as you should always use this one and never use that one, you know. I think there's certain contexts where the sort of holding a controller or a handle for this phantom, like doing the kinds of selection tasks I was doing before. This is one case where you could imagine, like, this thing looks a lot like a stylus, right? So you can, and actually we talked about doing these experiments when I was years ago, and then just never, we had one of these devices in the lab at the time, and it just, my research just kind of went in a different direction, and we kind of gave up on the haptics part. But that was something that we thought about, was if you could, you know, hold the handle on the phantom like a stylus, you could imagine doing these kinds of selection experiments, and, you know, rule out the effects of tactile feedback in that case. But I suppose you could also do the same thing with, you know, a bunch of wooden posts, right? You could have a bunch of wooden poles, and then you have your passive approach to the same thing. I don't know. I'm not really sure which would be better in that case. For the kinds of, you know, the kinds of approaches we're using now, like the basic problem with these props is they don't generalize, right? If you want to track a rubber spider, then that's great if you have a rubber spider. But if you want to track 50 things in your environment, now you need 50 trackers, right? Which it doesn't scale, it doesn't generalize well, which is where these approaches like haptic retargeting come in, because it gives you some ability to generalize these. And then this kind of approach further lets you generalize. I mean, this obviously is, again, not a silver bullet solution to all haptic shapes, because this maps onto a few different shapes reasonably well, but not perfectly. So I don't know, it's I don't really have a great answer to this. I think all I can do is kind of expose the problems better, you know. It's
I think it's funny how you when you start trying to represent multiple devices with the same haptic props, the prop is getting more and more complex and closing the gap to the active devices, to the heavyweight haptic interfaces.
Yeah. Yeah, that was something we were very conscious of when we were designing this. And the original version you see here was self-actuated, right? Like this did not have any motors in it. It's literally door hinges holding this together with some potentiometers inside to measure the bend angle, you know. But this was all done manually by the user. So you kind of have, you know, in a sense, you're kind of relying on the user to actually fold the thing into the shape that makes sense for the object that they're seeing.
Did it work?
Sorry?
Did it work for the user?
Yeah, they did. I mean, like that's what this study was really about, was just to kind of almost like a proof of concept to see if you know, what shapes would people pick for these things? Would it be a close approximation or not, or did it not matter? And we found was that people would tend to actually try to match the shape reasonably well, but there's certain parameters that are harder to match than others. Like, for example, you know, it's very hard to fold this into a shape that's appropriate for a skinny pen, for example. And so that's where we'd see the most variability in what people were picking versus something like this hammer. You know, everyone pretty clearly rolled it into the pretty well the same shape, you know. So there was great consistency in some shapes and less consistency in other shapes. But that's...
I thought about more in the other direction. So if I, as a user, have a device and have to fold it in the first place in order to receive better haptic feedback, let's kind of reduce my experience. Okay, you talk about a lot about efficiency of interface in terms of speed, precision, etc. But what about the user experience? So the feeling of using this and that.
Yeah, and that's probably where these kinds of things come in more. It's something I haven't really looked at too much, but it's something we're looking at a little bit more now. And in the study we did with the follow-up device here, the self-shape changing one, this one we did actually look at some user experience parameters, and I mean, most of this appears in the paper, but there's, you know, we looked at some things like you know, basically like their perceptions of difficulty and their perceptions of how well it fit to the shape they're presented and these kinds of things. And specifically in this study, we were comparing this to, we called them non-matching proxies, but basically styrofoam balls, and you know, with and without haptic retargeting, because we wanted to kind of split this apart and look at both. And then also we had matching proxies that were essentially, you know, like some kind of plastic 3D printed shape or something like that. That was a close fit for the objects they were grasping. And so this was something that we got at a little bit here, was around, you know, basically what was the experience of using these things like. Now we were still mostly looking at sort of quantitative performance measures here for this study. And we were looking specifically, they were doing a docking task. So they had to, like, you know, they'd have to pick the object up and put it in a certain position and oriented in a specific way to match a silhouette. Yeah, it's something that, you know, I think there's room to look at this stuff more, but it's not something I've looked at too much in the past. I mean, typically, when doing these studies, like for example, these kind of selection like studies, often I'll have a questionnaire or something like that that'll ask about some subjective metrics around their basically getting at their experience. How much fatigue did you experience with this? How much difficulty did you have? How fast do you think it was? This sort of thing. But it's usually less central. I mean, I've traditionally been more concerned about the performance measures myself, but it's obviously it's a worthwhile thing to look at in terms of UX as well.
Sorry, Rob.
Okay.
Ja. Ich glaube, Susanne had, I think Susanne had a question. So.
Yeah, I think maybe just adding to some of the elements you have presented, I was wondering where we are going with regard to weight, because all of these objects have, of course, have a haptic experience, and I think you've shown excellent elements of that, and where we have a strong anticipation of how, even if it's the same object, if I have a, let me see this is a mug here, sorry, here. That mug, if it's full or empty, so the sensation is extremely strong.
Yep.
So any suggestion where we would be going with the sensation of weight of an object in addition? Because of course, it might be okay with a single object, because then we can make it at a certain weight. You can whatever material you put into that. But the question will probably with, let's say, using a bottle of wine, and while we empty it, it gets lighter and stuff like this. Yep. A glass of wine that gets heavier. Any ideas where this is being done? If it will be an illusion, or if it's more on this on-body sensations, that would be interesting to hear.
I know people have been looking at simulation of kind of like center of balance. So they'll have like a device on a shaft that can slide up and down the shaft to kind of change the way the thing balances. Simulating weight itself, I'm not aware. I mean, I think there's been different things done with like pulley-like systems, like with like wires and that. And the one that comes to mind is the SPIDAR. 1 second here. This is the nice thing about doing this on online is I think I can probably find this here. Let's see, is there an image of it somewhere? Yeah, there we go. So these kinds of devices with a kind of a wire and pulley mounted thing, where you can kind of simulate a sensation of weight with these kinds of things. And so basically it's got pulleys in that they're pulling wires in a way to simulate weight. And these can do that kind of thing. But like in terms of, I mean, in a sense, haptics is simulating shapes, at least, is almost an easier problem than simulating weight. It's and certainly the kind of the scenario you're describing where you have, something that's sort of dynamically changing weight and you want to match the shape of it over time. It's like, well, that's hard, I don't know technologically how you do that, but I don't know. It's like, it gave me an idea though about a study. You could imagine doing a study on this to figure out, how much does this matter? You could use these haptic retargeting approaches to say, I've got the heavy version and the light version of the model, and I could use haptic targeting to get the user to pick up whichever one I wanted them to at a given time. You could probably evaluate weight perception that way and see how much it contributes to their experience with the system. But this is, I don't know. Weight is a hard problem.
I'm sure.
I had a student last year in a course project that didn't really work out. Tried to develop a, I don't think he was trying to do, I think it was weight simulation as opposed to center of balance, but he had like a spinning, like a motor, a thing on a motor with a counterweight on it or something spinning to kind of pull the object in one direction or another, but it really didn't work out in the end. But that was kind of right around the time the pandemic hit. So a lot of projects, we were sort of in week 10 of a 12-week course, and all of a sudden the pandemic started, and all the projects kind of blew up. So I don't blame the student for this. Yeah, weight's it's a good problem. It's a hard problem.
Thank you.
I don't know if that's
just wanted to add a bit. There is not a lot, but some work on this topic. Basically, I sent a couple of papers in the chat on basically weight shifting devices. So devices that a couple of weights and shifting around in order to change the center of mass or the
Shifty. Yeah, that's the one I was thinking of. This is Adalberto Simeone, right?
That's Andre Cena.
Oh, really? Sorry, wrong. Yeah, sorry, I'm thinking of the wrong guy. Right. Well, there's that one, but which one's? Okay, yeah, right. And what did Adalberto do in this area? But Shifty was the one I was thinking of.
It's basically a weight which is moving along some of the direction, and I think they later combined it with some positional illusions to simulate even more things, and that's where the work with Adalberto Simeone. You remember, I think, so there is some work in this direction. It's ongoing topic.
Yeah.
A couple of other devices were proposed, including some of them that just pour more or less water in the device to change the mass, not only the mass distribution. But it's a really interesting topic.
Yeah. Well, and this is something too, like it's something my colleague here, who I was working with on these shape-changing devices, and she comes from sort of this organic user interfaces world where they're doing a lot of these shape-changing and texture changing and so on kinds of user interfaces. And so she always has these ideas around these things, like, well, yeah, like what you described there, we could have a pump that fills the thing with fluid or air or something like that, and now you've got this like a rubber ball or whatever that changes its shape or its pressure, or it's it's kind of a different world than what I'm used to, but there's definitely some neat ideas out there. It's something like I have a hard time envisioning how a lot of these objects like there's something attractive about sort of the simplicity of a device like a mouse, or like even your sort of, this is not a good example, but your sort of typical VR controllers are something not far off from this, right? And I have a hard time envisioning how these complex haptic devices would sort of fit into your regular desktop world, and in particular, like our device presents a few different shapes, right? And if you want to present more shapes than that, then you're going to need another device. And then if you need more shapes than that, then you're going to need another device. So I don't know, like if the answer is you have a small suite of devices that change shape to map onto a range of different things sitting on your desktop or whatever, or one of these large scale general purpose, phantom-like or shifty-like kind of devices. I don't know. It's I have a hard time believing that those will sort of become like a standard thing that's just integrated into your workflow. It's
well,
I don't know.
Yeah, Klaus?
Yeah, also thanks a lot from my side for your nice talk. One part that you skipped, or basically just briefly mentioned, was the eye tracking part, and we already have had a couple of talks in these conversations that looked a bit in the eye tracking aspect. So I was wondering what your take is here.
Yeah, sure.
How can eye tracking help us here with interacting in VR?
Yeah, I can talk a little bit more about that. And sorry, like I said, I think I used a much longer presentation than I should have here. So there's too much stuff in there. But anyway,
that's fine. We can ask questions.
I'll talk a little bit more about this. So just to give a bit of context on this project, this came from basically my personal experience with the HoloLens. I got a HoloLens, and as you're probably aware, it's a Microsoft product. So the first thing you have to do with a HoloLens is sign in using your Windows account. And so this is a couple of years back, and I got the HoloLens and I started setting it up, and had to sign in. My Windows account password is something like 25 characters long. And basically, you know, text input on the HoloLens at the time was, you get a, I think maybe still the same, I haven't used it recently. You get a keyboard floating in your face in front of you, and you're aiming at each key with your head, and then doing this to basically click each key. And so needless to say, I made a typo in my password the first kind of 3 times I tried this, and had to go back to the drawing board and restart the setup process repeatedly. And by the time I finally got the HoloLens working, I was so thoroughly disgusted with this head-based keyboard typing that I stuck the thing in a drawer and didn't look at it again for about 3 months, you know. And finally I got it out later and kind of realized, yeah, okay, there's some things it does well. But anyway, so this is where this project came from, which is sort of my frustration with this, what I called head-based selection. And we had this eye tracker in the lab at the time. You can see in the image here, the FOV, which was like one of, if not the first kind of low cost, commercially available head-mounted displays that had an eye tracker integrated into it. And so essentially the question was, well, can you do any better with the eye than you could with the head? You know, like this head-based selection, we found it very frustrating and cumbersome. So we did basically a Fitts law type study again, but essentially using the eyes to, like, you're gazing at what you want to select in the environment, and compared that to to this head-based selection. And ultimately, I can show you briefly what this looked like. I'll turn the audio off. And you can see, yeah, the head-only conditions. So this is kind of your standard Google Cardboard or HoloLens type interaction where you're aiming with your head. And then the eye-based technique, you'll see immediately, you can probably guess the result based on how jittery that cursor is, just because the eye tracker in the FOV wasn't particularly great. You can see there's a bit of noise in that. And sometimes you can see it even jumps pretty significantly far because it's lost tracking or something. Long and the short of it was, we found that the head-based technique was actually better, which was for me pretty disappointing. But this is, you know, this is possibly attributable to just the eye tracker itself in the FOV. You know, the HTC Vive Pro Eye may have a, you know, we haven't tried this study again since. It may have better results with a better eye tracker. But more commonly, like we did actually follow-up study on this where we're looking at navigation through 3D environments using the gaze direction. So basically you're looking where you want to go. And kind of the advantage of this is you can potentially decouple the head orientation from the movement direction. So you can kind of, you know, not necessarily follow the direction your head is pointing. And so we tried this. It sort of worked. It causes a lot of cyber sickness. It's sort of like flowing through the environment along a motion vector. It's about as bad as using like a joystick in VR. It's something you don't really want to do, right? So I don't know. I'm a little bit reluctant about using the eye as, you know, as an input device per se in VR. There's other things it can be used for. I mean, more commonly, they're using it for so-called foveated rendering, right? Where what they're doing is they're figuring out where your foveal vision is looking, and they're kind of rendering that part of the scene in higher definition than the rest of the scene, because you can't see the high definition outside of that area anyway, right? So this potentially saves you some computational cycles and things like that, right? I think this is kind of, if you go look up eye tracking in VR, I think that's kind of like the top killer app is this foveated rendering. But there's probably other things it can be used for too.
All right, thank you. Just one follow-up question. Did you try to look into using eye tracking in combination with other interaction methods?
In this study, we looked at the combination of the eye plus the head, and so basically, like you have like your head-based approach, you have your approach where your head is fixed and you're just using your eyes, and then you had one where we used both together. And as you can see in the graph here, that one didn't do so well either. But beyond that, we didn't look at combining it with anything else.
So not with like hand interaction or something.
No, that's something worth thinking about though.
Okay, cool.
Yeah, I think we have a question from Tobias.
Hello, yeah, thanks for showing us your amazing works. One question from my side. Often there is not the possibility to use different kind of controllers. So you want to write a simple app for virtual reality and you have to stick with what is provided to you. Do you have some guidelines or personal experiences how the user interface and the interaction with others should be done for standard controllers? So what do you have some advice for me?
For if you're going to choose a particular controller?
Yeah, so if you're, for example, using the Quest and you have to use these controllers here. So what is the best way to make interaction, object manipulation, and all the basic interaction stuff you normally have in applications? Yeah,
this is one of the hard things about these modern development frameworks for these things, right? Is they hide a lot of the details under the hood, and just sort of this is what you get, right? And I found the same thing with, for example, trying to do experiments in stereo rendering, for instance, that it's just, say to the student, well, adjust the eye separation. Oh, I can't. It's just, you just click a thing here in Unity and now it's in stereo, So there's something to be said for the kind of the old way I used to have to do this stuff, which is I get out C++ and OpenGL and just start hacking away and having to do everything from scratch myself. So this is, I don't really have a good suggestion. I mean, generally, like if you wanted to not use the stock controllers in these things, then you're kind of looking at some serious level of hacking, trying to get another tracking system incorporated into it, for example. We've done things with, well, actually this, I can show you actually this, which was it? This project here. I don't know if you can see it in the video. You can't really see it in this video. I think if I got a better video of that. Well, this was one where we actually had to sort of hybrid together a whole bunch of different trackers to make this project work, where we were using a combination of an Oculus Rift CV1 controller plus a leap motion to track the user's hands, which you can see kind of the hand skeleton in the image here, plus a Razer Hydra magnetic tracker to track the actual device. And you actually, it's not shown in this video. This was in a later video. But basically there's a little you see this in a later video. It's on my website. I'm not going to pull it up right now, but there's a little white box where essentially we had extracted the magnetic sensor coils from the controller of the Razer Hydra and put them in a little 3D printed box instead, which then basically turned it into a little, self-contained tracker unit. So this is all done in Unity, right? And so we're kind of like, you immediately run into all these problems of having to line up multiple different coordinate systems, right? Because they're all in some different coordinate space, and you're trying to align all these things so that everything is in the same place at the same time. And then, but if you can do this, like you can potentially use, we've got a Vicon system here, or you could use a, natural point or whatever kind of tracking system you have. Once you can track something, you can do whatever you want with it, right? And Unity has plugins for all these kinds of trackers. So you can get the coordinates, and then, in this case, we're using Arduino control the shape changing of the unit, but you could use that to detect button presses, for example. So in a sense, you can kind of build your own controller, but it's not an easy, straightforward thing to do, right? Like it's I would probably go as far to say, by design, it's not an easy thing to do, because I don't think Oculus wants you to easily be able to replace their controller, or HTC doesn't want you to, right? So I don't know. I don't know if this answers your question.
Yeah, it gives me a little experience that I think there's always the same issues you struggle with, like the coordinate systems. So I use the OptiTrack system once, because you can track everything with that. But then it's difficult if you want to use the basic controllers. So you always have to, make some kind of own build solutions for that. Tracking is working. So that's sometimes a little bit annoying.
I remember marking off things on my table and saying, so I know that this is 10 centimeters in each axis, and then I could, I could draw a box out and say, okay, so what's the coordinate with this controller versus that controller, and then kind of figure out what the mapping is from one to the other.
But in the end, you would suggest that building own controllers with more possibilities is always the best way than just using the standard stock controllers and doing some kind of fancy stuff with the software.
Well, not necessarily. Like it's there's it's just like my answer about haptics, right? There's kind of room for both approaches, and it really depends on what you want to do. Sometimes you want a capability that stock controllers won't provide. I don't know, maybe you want an additional degrees of freedom. I mean, maybe you want a trackball or something on the controller itself in order to do in-place rotations or something like this, and clearly that's you could do that in software, and you could remap a joystick or something like that, but maybe it doesn't give you the kind of experience you really want, in which case then you're kind of stuck building your own device and then try to convince people that it's a good approach, right? On the other hand, like the software approach, I don't know, it's like a lot of what I'm doing, like we're sort of in a sense kind of figuring it out on the fly, what the better answer is for a given project, and it's often, I mean, if it's something that you want to mass deploy to people and have people use, then you're kind of stuck with using the stock controllers and thinking of a software solution, because it's hard to convince people to say, here's my crazy new VR controller with a trackball integrated into it. You should buy this instead, and you don't have the same level of entropy as like Oculus has, for example, right? So it's, what I mean? It's kind of you have to strike a balance here, right?
Yeah, thank you very much for these answers and your
Well, thanks
and sharing what you think about that topic. Thank you.
Yeah.
Okay, just we still have a couple of minutes, but Susanne.
Yeah, I don't want to sort of go first if someone else has a question. I have I was wondering, what do you think of haptics in mid-air? So far we have been talking about this real thing, I am touching a table, and this is actually a cool and challenging problem. But then, I don't know, in mid-air, you get your virtual, let's stay with the classics, laser beam sword, so, and now it's making sound and it's getting hit and so on, What do you think? Is that then easier because you have it in your hand and then you just actuate the glove or whatever surface you put on your hand? And also on the design of that, if I do a virtual gesture mid-air, and then I kind of get whatever, a magical ball, and then I think there has been work like this, but I think this idea of does it have to be bound to real physical artifacts, or can it be like any kind of magical thing that hits you, and have you worked on that?
I haven't really worked on this kind of thing, but again, it's like in general, these sort of in-air haptics, this is a hard thing, right? And it's I mean, there's devices out there like the ultra haptics thing where they're shooting ultrasound at your hand, right? And they had a demo of this at Kai a couple of years ago, and it's showed up at various VR conferences. And you know, if you haven't tried this, you know, essentially you're reaching out into space and it's blasting ultrasound against your hand when you're moving through the position of objects, and you kind of get this sensation of like I don't even really know how to describe it. It feels kind of like wind.
Yeah,
right?
I think I tried. I think it's Sriram was one of the people trying, or like
Yeah. And again, like it's a cool thing to try. It doesn't really simulate the effect of like you can't like grip something and feel like you're, you know, it like what we want is like the Star Trek holodeck, right? Where you can walk out and there's a virtual wall there and it feels like a wall, right? But it's, you know, they have basically magic sci-fi technology to do that sort of thing. I mean, in terms of like people have looked at, and I think this is what those Meta or Facebook or whatever they're calling themselves now.
Metaverse.
Gloves, yeah, Metaverse. The gloves are, I think they have vibrotactile feedback in them or something like this. So like they're it's like the same kind of, you know, vibration motor in your phone, right?
Yeah.
So you get kind of this buzzing sensation, but again, it's not simulating weight like you were talking about earlier. It's not really simulating the effect of, you know, physically gripping the thing. It's just kind of like when my finger collides with this thing, I get a little buzz it's not really the same thing. But it's kind of, I guess it's kind of the best stand-in that you can get given how hard the other alternative is, you know? Yeah,
I was wondering if maybe sometime they will also, I think we have people here from different backgrounds, like in material sciences, like you have really something that gets stiff or warm or cold. So you have a closer sensation because that magical glove you wear is able of doing it.
Yeah, and that's something I was mentioning before. My colleague in sort of this shape-changing UIs world has ideas around this kind of thing. Like, you know, maybe you have a glove, and I mentioned earlier, like you know, an object that you're inflating or pushing fluid into with a motor or whatever, but you could do something similar with a glove, right? And imagine you had little fluid bladders at the end of each fingertip, and you could kind of create a sensation of pressure inside in the fingertips and actually activate the receptors you would want to activate if you were actually, you know, gripping something or pressing your fingers against something. It's like reminds me of, like Dimitar, you said earlier about this, you know, no silver bullet. It reminded me of that really old paper now by Foxland. You probably know this one, right? Where it's motion tracking, no silver bullet, but a reasonable arsenal. You remember that one? This is basically the argument, and I think haptics is a similar problem where, you know, we've got a lot of different, when Foxland wrote this, we had a lot of different 3D tracking capabilities, but no sort of magic answer that was going to solve all tracking problems. And I think it's similar with haptics where, you know, there's no really one good solution that works universally and perfectly. It's more like you have to use a combination of these things to kind of simulate different senses. You mentioned temperature earlier, and this is, you know, this is another one that's.
I always wanted to work with, I think I'm not sure if I can say this in a recorded video, also work with pain. So the question is, so how far would you go with pain? There's certain areas where it actually makes sense, even though it doesn't sound politically correct in the first place. As this is also about visions, my thing, you showed a lot of interesting things, but if you were, you know, on that holodeck, so what would be the application? You said this is what I would bother about the most, what I would strive for the most, because you think this is something I really want to have. It could be gaming, of course, which is a natural thing, but what do you think would be what you would imagine being done in, let's say, 5, 10, 20 years?
I don't know, that's a good question. I always tend to think of the applications as that's somebody else's problem.
Okay. But you might have in real life, you might have something that you said, oh, if that would work, you know, it would be also a great benefit to me.
Yeah, it's this is Doug Bowman gave a talk at, he was one of the keynote speakers at VRST last year. And his argument was that the kind of the killer app for these kinds of technologies is general purpose computation. That, you know, that essentially you could replace your desktop with these kinds of AR or VR systems if the technology was good enough, and do a lot more, you know. And I think this is kind of the direction that Meta is going in, right? So I don't know if that's necessarily what I would envision as being the killer app for this. Hey, I can do spreadsheets in VR now because the technology's finally caught up. You know, gaming, I think, is definitely an attractive option. I think it's sort of turning out to be, right now at least, the killer app for VR is, I think, is gaming as of the moment anyway. But this has always been sort of one of these things that VR people have sort of struggled with, right? Ever since it became technically possible to do this kind of thing, as far back as the 80s, and maybe even before that. You know, what's it any good for, and how do we justify doing this when it's so much harder and so much more cost effective, and probably less, you know, potentially a worse user experience, but potentially less effective from a user interface perspective? Why do you justify doing this when you could do it better in a desktop? And what applications are there about VR that make it so special, and you know, that you can only do in VR that you can't do?
Well, we have a mixed reality project that is actually related to this Corona times, where for most elderly people couldn't see their children and grandchildren, and we wanted to have a question: can I create an immersive mixed reality grandmother's chair and have her meet maybe her niece or whatever, and then what kind of course you can do extremely cool immersions, but what of these immersions are actually really creating a social connection between people? You know, it's not about, for me, that would be an interesting thing. Can I really, not necessarily only the physical touch that might be interesting to have someone hug me, but also creating an immersion that leaves my heart touched in that sense. It's not only the physical touch, it's also me being connected, me feeling, well, me feeling loved. Maybe that's a big word here, but that's something we are trying to research here. And then it's also interesting, you know, an immersion is only part of it. But the way how it is presented and how it is embedded in that holodeck thing is also an interesting thing. You can think of it as an application, but you can also think of it as an element of that design that contributes to, for example, a social connection. It would be interesting to see how that works. Yep.
Yeah, this is something I've been thinking about. I think a lot of people have been thinking about, actually, this idea of, hey, these immersive technologies are great communication platforms, particularly in the current times of Zoom meetings and things like that. It's there's potentially something there, you know.
Yeah, cool. Thank you.
Thank you.
So thanks, Rob, for joining us today.
Well, thank you for having me.